A very good morning to you all students. I hope that you all are fine and safe at home. Students, are you ready to listen the class? Okay. So I welcome you all to the chemistry online class. Today we are going to discuss about the topic metallurgy. It's a very interesting topic. So listen carefully. So first we can see what is the importance of metals in human life. See students, metals play very important role in our day-to-day activities, and also it play important role in our human body. You know that some of the metals are very important for our normal metabolic functions of the body. Can you say some examples? Yes, you all know, isn't it? Our bone and teeth contains which one? Calcium. Iodine is necessary for the functioning of thyroid hormone. Similarly, manganese, cobalt, zinc, etc. act as the enzyme cofactors. So, metals play very important role. The deficiency of some of the metals in our body result in diseased state, isn't it? And also, for the diagnosis and for the treatment of certain disease also, we need metals. And also metals day to day our activity we are using in the form of utensils. Copper is used in electrical wires, aluminum as electrical wires, isn't it? At car batteries, at the home we are using stainless steel which is made up of metals, pressure cooker, etc. So most of the utensils are made up of what? Metals. So metal is a important thing for human life. Now we can see the definition for metallurgy. So what is metallurgy? Yeah, study of metals. It is the art or science of extracting metals from their ores and modifying the metals into alloys for various uses is called as metallurgy. So totally we can say as common as how these metals are extracted from their source and how they are modified, purified and used for several purposes. That is called as what? Metallurgy. The study of metals. How these metals are extracted, from where they are extracted, how they are purified and how they are modified into other substances like what? So many substances above I said the examples, isn't it? Electrical wires, car batteries, how these are modified. Okay. And see, most of the metals are used in the form of alloys. Okay, so here we can see in the definition, extracting the metal from the ores. Ores are found on where? Earth crust. Ores are found on the earth crust. It is the mineral, isn't it? Ore is the mineral. Minerals are gives wealth to our country. So ore is the mineral which is found under the earth crust from where metal can be extracted. After extracting, what they will do this metal? They will modify the metals into alloys. What is alloys? Alloys are the homogeneous mixture of two or more metals, isn't it? From the lower class itself you have studied this word alloy. What is alloy? Alloy is the homogeneous mixture of two or more metals. That is you can mix metal with metal or metal with non-metals. For example, for gold we can say pure gold. Pure gold is too soft to be used and it does not give good tensile strength. So to make it a good tensile strength, to give it more strength, we will use little percentage of copper which enhance the strength to what? Gold. Okay, wow. So pure gold means 24 karat, isn't it? So normally we will use gold in the form of alloy with the copper. Okay, so that is called as what? Alloys. Have you understood? What is the definition for metallurgy? Metallurgy is a science of extracting metal from the ores. After that they are modified into alloys. Alloys means what? It is a combination of two or more metals. For example, only I said gold. Am I right? And this alloy, how it done means, how the mixing of metals done means, based on the physical and chemical properties and also the structural arrangement of atom based on their properties. For example, gold, it has a shiny appearance, so it is used for ornaments, but at the same time they are not giving high strength, so we are mixing copper with that. So studying the physical and chemical and the arrangement of atoms, we are modifying the metals into alloys. Have you understood what is metallurgy? Now we can move into the principles of metallurgy. Principles of metallurgy. So what are the steps, or you can say the steps involved in metallurgy? General principles of metallurgy. First step, usually the first step is mining. Okay, it's a preliminary step. After pulverization. Pulverization means after taking the ore from the earth crust, that process only we will call it as mining. Next they will do pulverization based on big balls, mills. They will cut that. See, actually ore will be in the form of a rock, isn't it? So they will make it into small pieces. That is called as pulverization. After that, three main steps are involved. We can see what is the three main steps. Okay, first one is the separation of ore. Separation of ore. So concentration of ore. The first step is concentration of ore, or you can say dressing of ore or separation of ore. What is that concentration of ore or separation of ore? It is a process of removal of impurities from the ore. Concentration. So after taking ore from the earth crust, see, it is combined with a lot of impurities as it is taken from the earth, isn't it? So there will be a sand, clay, so many impurities are attached to our ore, so that should be removed. That is called as dressing or the separation of ore or the concentration of ore. That is the first process in the metallurgy, the removal of impurities from the ore. Okay, the next one is the extraction of metal, or you can say it as the production of metal. Extraction of metal or production of metal. See, the concentration or the separation of the first step is done by so many methods based on the ore. Based on the ore it is done. Okay, that later on you will study what are the steps, what are the process are there to remove the impurities. Okay, so first one is removing impurities. Next one, production of metal. Here also a lot of methods are there. We have, after removing the impurities, the ore is subjected to the extraction of the suitable metal from the ore. It will be happened. That is by what are the process it will take means we can do calcination, roasting. It is the two main steps that will be done while extracting the metals, and also so many steps we will learn in the production of metals. Okay, see, here is a flow chart which detailedly tells what are the steps that's involved in the metallurgy. So first one is mining, next one is pulverization, followed by the concentration of ore by various techniques like gravity separation, magnetic separation. Next one, what? Flotation and chemical leaching. These are the methods used in the concentration of ore. Second one, what? The production of metal. So many techniques are there with the help of carbon, with the electrolysis, etc. The last one is refining of the metal. First process is what? The refining of the metal is done by the following method that you can see in the flow chart. The liquefaction, so many examples are there. Last one, we will get our pure metal. So what are the steps? What are the general principle? One is dressing or the concentration of ore. The next one is production of the metal. Third one is refining of the metal. After this process, we will get our desired metal in the purest form. Okay. The next we are going to learn about terminology. We are going to learn about what? Terminology. Terminology means some of the definition or some of the terms that are commonly used in metallurgy. First one is minerals. What are minerals? You know that minerals are found, it is a naturally present substance. It's naturally occurring substance under the earth crust is commonly called as what? Minerals. Under the earth, mineral may be in the form of a single compound or it may be in the form of complex mixture of various compounds of metals. Okay. So what is mineral? Mineral is a naturally occurring substance present on the earth crust which contains the metals in as a single compound or a complex compound. See, some metals have high reactivity. Some metals have low reactivity. Ninth, you studied the reactivity series, isn't it? So, some elements they are highly reactive and they will be found as combined state, and few metals like what? Gold, isn't it? Gold, platinum, okay, silver. These all exist as a free state. Some metals, due to their low reactivity, they will be exist in free state. Other all be in the combined state. So minerals are it may be of single compound or a complex mixture of various compounds that found on the earth. And the minerals can be also called as ore. How? What is that ore? Let us see. See, the minerals from which the metal can be extracted in profitable amount, that is called as ore. Okay, so all the minerals can be called as ore, but all the ore or cannot be called as, all the ores are called as what? Minerals, but all the minerals you cannot say as ores. So now we can see the difference between mineral and ore. It will be clear for you by seeing this what? Example. Shall we? So keep in mind, students, minerals, they are found under the earth crust as a complex mixture or a single compound. Or from this mineral, if we take metal in a profitable bound, then that mineral is called as ore. See, here is an example or extraction of aluminium. Clay, it is also contains aluminium in it. Bauxite, it is also a mineral contain aluminium in it. The formula for clay you can see in the video. See, Al2O3 2 silicon dioxide plus water. Bauxite, aluminium Al2O3 dot 2H2O. This is the formula. Both are considered as minerals because they are found in the earth crust as what? Minerals. In both it has the metal aluminium. Both has the metal aluminium. So for extracting the metal, which one we will choose? Clay or bauxite? Both are minerals that contain aluminium. But if we choose clay for extracting aluminium, you won't get a profitable amount. You will get less amount of aluminium. See, we are the cost that is we are doing for the extraction process of more, isn't it? Mining you have to done, pulverization you have to done, so many process we are doing for extracting a single metal from mineral. So it costs a lot. But if the profit is not there, if a suitable amount of metal is not extracted from the mineral, means what is the use? No, isn't it? So what we will choose? Clay contains less percentage of aluminium, whereas bauxite contains high percentage of aluminium. So for extracting aluminium, we will choose bauxite. We will never choose clay. So this bauxite is considered as ore of aluminium, whereas clay is considered as the minerals of aluminium. Have you understood? Some bauxite you can extract the profitable amount, hence bauxite is called as ore, where clay is called as mineral. Now have you understood the difference between minerals and ore? So ore is also a mineral. If any metal that can be extracted in large percentage in profitable amount, then that mineral we will call it as what? Ore. See, here are so many examples. There are different types of ores. See, if it is combined, if the elements are combined with oxygen, we will call that as oxide ores. For example, bauxite, cuprite, hematite. These three are considered as oxide ores. If it is combined with the carbonate, they are called as carbonate ores. So, marble, magnesite, that is calcium, magnesium, iron, mostly combined in the form of carbonate. So they are under the earth, it is in the form of carbonate ores. Okay, halide ores means metal that combines with the halogens like fluorine, chlorine, etc. So what are the examples? Cryolite, fluorspar, rock salt. If metals are found to be attached with sulfur, then we call that as sulfide ores. For example, lead, iron, zinc, mostly they will found under the earth crust in combination with the sulfur. Then they are called as sulfide ores. Have you understood, students? So, minerals from where the particular metals can be extracted more, then we will call it as ore. Okay, less percentage means we will call it as mineral. So these are the examples for different types of ores that are found on the earth crust. The next process is mining. You know this topic, isn't it? Mining. The process of extracting the ore from earth crust is called as mining, isn't it? From the deep of the earth crust we are taking the ore outside. After that only we will do all other steps. So the first step is mining. So that is called as the extracting the ore from the earth crust is called as mining process. Okay, ma? Have you understood, students? The next one is gang or matrix. The next terms that commonly we will use in metallurgy is gang or matrix. Gang or matrix. What is this gang or matrix? I said first of all, concentration of ore, isn't it? In that what we will do? We will remove all the impurities associated with the sand clay. See, like that. The impurities only we will call commonly as what here? Gang or matrix. The rocky impurities. The ore will be in the form of what? Rock, isn't it? After removing all the, see along with this ore, it is look like a rock. This rock what surrounded by what? Unwanted substance other than the metal. Other than our desired metal, what are the substance associated with that ore is called as what? Gang or matrix. So see, other than our desired metal, all the things that associated with that ore is called as rocky impurity. So that is called as gang or matrix. Here we will mention the rocky impurities as what? Gang or matrix. The next one is flux. Flux is a substance, it's a semi-substance, a chemical, a substance added to remove the impurities. So how to clean this impurity means by adding a flux. So to this ore which contain gang or matrix. Okay. For example, bauxite Al2O3 to H2O. Other than this bauxite ore, it may also contain some other metals. Okay, in smaller percentage, little percentage that is found attached to bauxite. Other than sand, clay, etc., some other oxides, some other sulfides, little amount also found attached to this what? Ore. That we will consider as what only? Impurities except aluminium. Remaining whatever thing that present in that ore we will consider as what only? Impurities, because we doesn't need that. We need only aluminium. So we will remove all the other thing from that ores. Finally we will get what? The pure metal. So except this pure metal, remaining everything being considered as what? Impurity. So the rocky impurity is called as what? Gang or matrix. To remove these impurities from our ore, we will add the flux. So two types of fluxes are there. One is acid. Next one is basic. One is acid, next one is basic. Likewise, the impurities while extracting the metal, several steps are there. Calcination, roasting, etc. are there. During these steps, the impurities formed in the form of acidic impurity or in the form of basic impurity. Did you understood, students? Not only sand and clay is considered as impurity, while extracting, isn't it? After the concentration, we will have to extract our desired metal from that ore. So the following steps, intermediate steps, so many impurities will be formed. Okay. For example, silica, if it is attached, it is removed in the form of silicon dioxide. Iron silicate. You see, with our bauxite, if little amount of iron is there, now we consider that iron as what only here? Impurities. So we will add silicon dioxide and it is removed as iron silicate. So like that we will remove all the attached particles from our ore except aluminium. So while extracting, we will get two types of impurities, either in acidic impurity or basic. If our impurity is acidic, we will add the basic flux. The common example, calcium oxide is a good example for basic flux. If our impurity is basic, we will add the acidic flux silica. To remove iron oxide, we will add silica. So it is removed as iron silicate. Like that. See down, a good example is given. From this you can understood what is basic and what is acidic flux. Have you understood? So if our impurity is acidic, we will add basic flux. If our impurity is basic one, we will add acidic flux to remove the gang. Okay, so if our gang is acidic, then basic flux is added and vice versa. So here is an example how the impurities are removed from the gang or matrix. The next one is slag. What is slag? When we add flux to gang, our flux reacts with the gang, that is our impurities, and they form a fusible product. Both forms a fusible product. That product only we will call it as slag. For example, iron silicate is called as slag. Iron oxide that reacts with what? Silicon dioxide and forms FeSiO3, that is iron silicate. Have you understood, students? See, if to remove iron oxide from any ore, we will add their silicon dioxide. So now our silicon dioxide reacts with iron oxide, which is considered as impurities, and the iron oxide is removed in the form of iron silicate. FeSiO3, that FeSiO3 is called as what? Slag. It is a fusible product formed between what? Gang and flux. Have you understood? Silicon dioxide is flux and iron oxide is gang. When they combine together, they form iron silicate, which is removed as slag. Have you understood now what is slag? It's a product formed between gang and matrix, which is considered as what? Slag. Slag means which is considered as what? It is also one of the waste product. Okay, that is has to be removed from the extraction process. Okay, while extracting copper, you can see this. While extracting what? Copper. See, copper contains little amount of iron oxide, and we should not need this iron oxide, so we will add silicon dioxide. So silicon dioxide reacts with iron oxide and removes iron silicate, that is called as slag. Have you understood? From the above equation, you can clearly understood. Okay, have you understood, students, what is slag? So these are the common terms that comes under where? In the metallurgy. Okay, the last one is a smelting. It is the process of the last step. Okay, so in each step we will remove all the impurities. The first step, the metallic oxide. So after removing all those, we will get our oxide ore or sulfate ore. That is, oxide ore means from bauxite finally it comes to Al2O3. Okay, for example, galena means lead sulfide, PbS. So the last step. So they will do means they will apply a high temperature and reduce the metallic oxide. The metals combined along with oxygen is called as metallic oxide is reduced. It is converted into a free metal, in the pure metal, in molten condition. Molten condition is melt. It will melt, isn't it? Because we are applying high temperature and we are doing several steps to remove the oxygen from our desired metal. So it will be our desired ore will be always in the form of what? Molten condition, melted conditions. Okay, so this process is called as smelting, the final process, that is the conversion of metallic oxide into metal. Metallic oxide into metal is called as what? As smelting. Okay, here is an example for smelting. From this you can understood what is the conversion of. Here you can see in the extraction of iron, see the last smelting process. Here Fe2O3 plus 3 moles of carbon monoxide. Here we added carbon monoxide here acts as a reducing agent. Okay, which removes the oxygen from the iron. And see, we get a pure metal, that is iron, plus the oxygen is removed in the form of carbon dioxide. This is called as smelting process. So for all the extraction of metals, the smelting process will be done in several methods. So what is reducing agents? Means which you can remove. This reducing agents here, carbon monoxide acts as a reducing agent which reduces iron oxide into iron. Have you understood? So that process is called as smelting. That process is called as what? Smelting. Have you understood? So these are the introduction part for metallurgy. The next class we will see what are the steps that is used to remove gang or matrix. That is concentration of ore, removing the impurities. 4 major steps are there. Next class we will study. So students, in this chapter you have to learn all the terminologies which comes under here for 2 mark question. Have you understood? Thank you.